Hey everyone, welcome to our meeting today. Really appreciate you joining. You may have heard a few weeks ago that MicaSense has partnered with Pix4D, and the intent of this partnership with Pix4D is to offer a solution for processing and analyzing multispectral data that incorporates the speed and reliability of Pix4D's processing software while still maintaining the analytics, visualization features, and scouting tools in MicaSense Atlas. My name is Drew Baustian. With me is Emily Ciesielski. She's in sales. I'm in sales as well at MicaSense. And we're happy to have Greg Krutzinger as well on the line. He's a representative at Pix4D. Greg's going to be serving as a supporting role for this call, and he'll be available for answering questions at the end of our presentation. So today's agenda is to go over the Pix4D licenses that MicaSense has available. How to process red edge data in Pix4D will also be covered. Exporting to Atlas from Pix4D, and finally we'll cover general Atlas functionality for those on the call who may have Pix4D but are unfamiliar with Atlas. And finally, we'll have some time for questions at the end. So Pix4D, in terms of Pix4D licenses offered by MicaSense, there are really two available, Pix4D Ag and Pix4D Mapper. Pix4D Ag is an image processing solution for those who are strictly involved in precision agriculture. So if you're someone who is solely using the Red Edge or the Sequoia for remote sensing, and all you're looking for are accurate reflectance maps and index maps, then Pix4D is potentially a good solution for you. But if you're doing multispectral imagery, and in addition to that, MicaSense has two different Pix4D licenses offered. One is Pix4D Ag, the other is Pix4D Mapper. And as I was saying, Pix4D Ag is a good solution for someone who's doing exclusively multispectral imagery and he's just looking for reflectance and index maps as an output. Pix4D Mapper, on the other hand, has much more functionality. So if you're not just in the agricultural industry, but maybe you're doing survey work and mining as well, Pix4D Mapper is going to be more of a holistic solution for someone in that position. So a little bit more information on the two plans, Pix4D Mapper and Pix4D Ag. Pix4D Mapper is going to be able to generate a digital surface model of the field. It can generate 3D point clouds, volume measurement, and 2D vector outputs. So again, it's just more versatile. If you're just doing multispectral imagery, Pix4D Ag is a great fit. Otherwise, we direct you to Pix4D Mapper. Both have unlimited desktop processing and cloud processing, but it really just comes down to determining what you're planning to use the system for. Imagery taken with the Red Edge is going to be automatically recognized by Pix4D since the cameras are in Pix4D camera database. So that's one of the benefits of the partnership. There's also a workflow to enter in calibrated reflectance panel shots for each band using the information, using this information as well as the DLS data. Pix4D automatically carries out the lighting calibration. So they have this, this is part of the Pix4D software to be able to utilize the downrolling light sensor data, or if you're using the sunshine sensor, it's going to detect that and help with the radiometric calibration. The upload to Atlas feature is a new addition to Pix4D that allows you to fully utilize Pix4D and Atlas. We'll get into some details on that in a moment. And MicaSense also offers bundle pricing on RedEdge and Pix4D, and you can find out more about that by visiting our website.
All right, thanks, Drew. This is Emily on the line here, and now we're going to transition over to going through a step-by-step of how to process RedEdge data in Pix4D. So just for the sake of time and to keep it concise in the presentation here, we've used some screenshots, and we'll walk through it all together. In this example, we'll be using Pix4D Mapper. So the first step here will be to create a new project. Choose whatever name for the project that you'd like. Save it wherever you'd like in documents or downloads, wherever, and then select the project type. So in this case, we'll be doing a new project. Next step will be importing the images. So after creating the name for your project and hitting next, it'll prompt you here with this new pop-up to select images. And you'll add the TIFF images, the TIFF files for each band. So once you've selected those, added them, it'll show you the total number of images selected and the file names for each. After hitting next, this middle image will come up here, image properties. So as you can see here, the MicaSense RedEdge is included in Pix4D as a recognized camera option. So it's already got all of the bands selected there and all the specs taken care of. So there's nothing to do in this middle screen here. We can go on to the next thing, which will be selecting a processing template option. So in this last image on the right here, you can see all the different processing template options available in Pix4D Mapper. In this case, we'll want to be selecting the Add Multispectral Processing template. So after selecting that Add Multispectral template, what will happen is that window will disappear and it'll show the flight plan basically for the flight in each area where an image was captured. So you can double check that and make sure that there's no missing gaps throughout the flight. And then move on to radiometric calibration. So this will be entering in the shots from the calibrated reflectance panel. So in order to do this, first we'll go to process and then all the way down to processing options on the menu bar. And then next it'll come up with the toolbar to show you all the different processing options available. In this case, since we're using RedEdge, we'll want to do the DSM, ortho, mosaic, and index as the processing option. Select that and then hit next. And so after selecting that, it'll pop up with this next step, which is basically to enter in the albedo values as well as the calibrated reflectance panel shots for each band on the RedEdge. So what we'll want to do first is for correction type, make sure that camera and sun irradiance is selected. So you can see here in this example image, for all 5 bands, we've got it pulled up and all of them are reading camera and sun irradiance as the correction type. And then next for each band, we'll want to select calibrate. So for this first one, for the blue band, that'll be the first example we'll show here. So after you select calibrate, it'll pop up and it'll give you an option to browse and select the correct TIFF file for the calibration shot. So it'll look something like this once you pull it up. And then what you'll do after you select that image is to draw a region on the panel image. So we've already drawn it here, but basically you're just drawing a box with that turquoise line. And then the last step there will be to enter in the albedo value from your calibration panel. So each calibration panel is going to be different. So if you don't already have the albedo values for your panel, you can contact us to request those values. So basically for this, you'll want to do that for each the same process for each of the 5 bands. So after you've done the radiometric calibration part, the next step will be to do the initial processing. So what you'll do is go back to the menu bar, view, and then to processing. And what'll come up here is this bottom image. It'll show number 1, initial processing, number 2, point cloud and mesh, number 3, DSM, etc. So all 3 will likely be selected. So what you'll want to do is unselect step 2 and 3, the point cloud, mesh, and DSM, and just start off with the initial processing. And then you can select start to start processing. And basically what will happen is that will run that initial processing, and once that's done, it'll pop up with a quality report once that's complete, and it'll show you a preview of the orthomosaic. So it's just a good step to do the initial processing first instead of all 3 at once, so you can take that pause, review the quality report, and make sure there's not going to be any issues with the orthomosaic. So after going through those steps, this is what you'll get as the output, the completed reflectance map. So you can see here, there's on the reflectance map under index calculator, we're looking here. You can see the minimum, max, and average values for each band there. And then in the index map area, you can see NDVI. So NDVI is going to be a vegetation index that is already entered into Pix4D, and so that's what we're displaying here as the default. If you want to add another vegetation index, what you'd have to do is manually enter the formula there. So similar to how they have for NDVI here, enter in whatever bands you're looking at there and the specific formula to be able to view that, and you can also adjust the color scales and things as well. So this is the completed reflectance map in Pix4D, and in order to upload to Atlas, Drew will talk us through some of those steps.
Yeah, so once you get to this point, after you've generated the reflectance map in Pix4D, under the export options on the right panel, within the index calculator, there's a button that basically says upload to MicaSense Atlas. And you'll click on that button, and at that point, the MicaSense uploader opens up, and you'll log in there. And the orthomosaic, the geotiff, and of the 5-band geotiff, and also the DSM file start uploading to Atlas. And we've got a view of that on the next slide, I believe. Yeah, so you do need to have an Atlas account set up prior to clicking upload to Atlas. So once you have an Atlas account set up, you'll actually have to, it's confusing to say, but you'll have to download the uploader in your Atlas account, and the uploader looks like this. So you'll click that button, the sensor data uploader will show up here. You'll log in, and it'll begin that process. So on the next slide, it shows you the 5 bands and the DSM uploading to Atlas. So if we're using the red edge, we've got blue, green, near infrared, red, and red edge. They're all currently uploading the geotiffs, and then you also have the DSM uploading at the top. And once this is done, then it'll show up in your data hub in Atlas as basically a project, and you'll click on that, and it'll say that it's preparing your data for MicaSense Atlas. So this usually takes 10 or 15 minutes, and then once that's complete, you'll have all of your layers, basically all of the data is going to be in Atlas. But if you don't have a field outlined yet for that geotiff, you'll want to go in and just basically create a field in Atlas that represents the area that you mapped. So this is just illustrating that step. So you'll click this create a new field. You can name it whatever you want, farm name, field name, and then create that, and Atlas will post the data to that location or that field boundary that you drew. So next we're gonna take a look at some of the analytical layers and visualization tools offered by our platform. So Atlas is going to deliver all of the standard indices that you're probably familiar with, such as NDVI, NDRE, OSAVI, even RGB if you're using the red edge. It's going to generate an RGB composite. And if you are using Pix4D Mapper, it's going to also display the digital surface model if you process that in Pix4D Mapper. So in addition to the standard layers and indices, we also have premium analytics such as the chlorophyll map and our weed detection layers. What you're seeing on the screen right now is weeds 1 on a potato field, and I've just cropped out a small area of that field that's got broadleaf weeds in it. I thought this was a great illustration of the weeds 1 map working well. So it's identifying those broadleaf weeds very clearly. So that's a great application for the weeds layer. Visualization tools in Atlas include the time slider for monitoring changes over time. You can see in the image on the right, kind of on the lower right-hand side of that image, there are 2 dates, January 5th and March 30th. So if you have captured 2 data sets over the course of time, there's a really easy way to go from one data set to the next. And because it's radiometrically calibrated, you can be confident that you're seeing changes in the crop and not changes in lighting conditions. We also have crop focus for reducing noise and focusing on variability. So this can be a great tool for crops that have wide rows, such as vineyards or orchards, where there might be a lot of plant life occurring in between the rows, such as maybe a cover crop or weeds or even just dirt that's showing information that you might not really care about if you're trying to analyze the plant canopy. But at the same time, it can be useful to isolate just the whatever's occurring in between the rows if you're looking for excessive weeds or if you're trying to understand how your cover crop is performing. So you can kind of go either way with that. From operation management standpoint, the utilization of the organizing of farm and field data can be very helpful. If you're covering data across several operations, just organizing the information by farm and field, that can be a useful tool. There are also annotations and scouting tools in Atlas, such as drawing a boundary around a region of a field of interest to get an idea as to what is the extent in acres of a certain characteristic of that field. You can also drop points and for scouting references later, take ground truthing pictures and add those to Atlas. So useful, basic scouting tools included as part of Atlas. And we also have exporting and sharing options. So one great feature about the sharing options is the ability to decide to what extent you're going to be sharing information. So if you just want to share one data set, one field captured at one point in time, you can do that. If you want to share a whole farm, which may be multiple fields with someone, you can specify the difference between those two. We also have a handful of different exporting options. So we have the ability to export the current view. So if you're looking at the chlorophyll map, for example, and you've got it honed in just a certain way that you want to export and use for analysis later, you can do that. If you just want to export the complete calculated indices, you can do that. So without adjusting the histogram, you just want the complete index, you can export that. Or if you just want the complete multi-band mosaic, the 5-band geotiff, that's also available for exporting. So those are just a few, just a quick overview of some of the features and benefits of Atlas. The pricing structure, it's broken down into 3 levels. So we have light, standard, and premium. The plans are based on the features included. So for example, crop focus, digital surface model, export and sharing options would be some of the features that may or may not be included depending on what plan you choose. The plans are still monthly, so you're not locked into a yearly plan, and you can always update the plan depending on your need. One really great benefit is the free light plan offers basic Atlas features, and it will allow you to store your data while not actively utilizing the export/sharing options or advanced analytics. And we also have a chart on our website that provides a comparison of each plan, light, standard, and premium, and a detailed breakdown of what each one of those delivers. So I'd recommend, if you're looking for more information on that, I go to MicaSense.com/pricing, or just go to MicaSense and navigate to the menu at the top of the page. So just to reiterate kind of the point of value of this Pix4D MicaSense Atlas combination. So Pix4D upload to Atlas feature allows for full utilization of Atlas on unlimited acres when processing locally through Pix4D. So just wanted to share like one of our customers, an example of how one of our customers is utilizing this partnership. So he's a service provider flying several fields throughout the season in remote locations. So he's capturing data all day, stays in hotels at night. The hotel internet is not adequate to upload 20, 30, 40 gigabytes of data for processing, for cloud-based processing. So he's processing the data in Pix4D Mapper. Once the data is processed in Pix4D Mapper, he can upload the geotiff to Atlas as a deliverable to the client. And Atlas is giving him a simple, easy interface for client interaction and analysis of that data. And another thing is the service provider can process as many acres as needed without the extra cost of processing. So if you're interested in Atlas, let's say you're using Pix4D and you're interested in Atlas, or you had been using Atlas and now you're looking into using Pix4D, you can request a trial of both of these on our website. So if you go to MicaSense.com/try-Pix4D, you can request a Pix4D trial. You can also request an Atlas account, and we have a trial of our premium plan that you can use for a period of time. So you can go to our website to find information on how to sign up for both of those. So again, apologies for the technical issues. I hope that didn't detract too much from the call, but we're going to open it up for some questions now, and glad Greg's here to help us out with those. So if anyone has questions, you can feel free to enter them into the questions tab on your little GoToWebinar navigator. So one of them is, this is directed to Greg. So Greg, I hope you can help us out with this. So it says, are you going to explain how to merge big projects and export them into Atlas? So Greg, would you be able to talk to the ability of Pix4D to process small batches and create and turn them into a large one? I think there's a functionality for that, but I'm not sure.
Hi guys, this is Greg from Pix4D in the San Francisco office. There's a couple of different options for generating big projects, and so it kind of depends a little bit on what you're talking about big in terms of area. You know, the camera features are treated as a rig within Pix4D. So even though you're getting, say, 1,200 to 2,000 photos, they're actually not treated that way in terms of the processing like the standard RGB camera would be. So it's actually each band is combined as a rig. So you're getting 1/4 or 1/5 of the processing power. Depending on the combination of the photos, there's a couple of different options for combining those projects together. You can process them all together as one job. There are ways to process them and tie them together after the fact. And there's also we have a lot of support aspects that I can go into in terms of how you would manually tie those points together or using ground control. I think the best option here would be to provide the MicaSense team with a couple of links that can be shared after the webinar for how you would either tie those manually together or using ground control after the webinar that can send you on processing those big projects.
Okay, thanks, Greg. So another one is from Glenn. He says, we've been using the Sequoia and it automatically detects radiometric cal images using the Aeronav calibration panel and QR codes. Does this not work for the Red Edge? That's a really great question. Actually don't know if I have an answer for you at this point. Greg, maybe you can shed some light on that. Is it,
yeah,
I suppose if you're using the Red Edge and you're using the Aeronav panel, it probably would work for radiometric calibration.
So currently we have the auto detection is good for the Sequoia, but not for Red Edge. That's correct.
Okay, great, gotcha. Got a few more. So one question is from another one from Glenn. How can we share with users in terms of a geotiff they can walk around with on their mobile device, overlaying their current GPS position? So I think this is like basically how can we scout with the data set. So that would be a great feature to utilize in Atlas. So if you do upload the data to Atlas, there's a geo-referencing tool in there that you can click on if you're out in the field with a tablet or even your phone looking at the data set. And it's going to drop like a blue dot where you're located and follow you around the field. So that's typically how our customers utilize Atlas for scouting purposes. One question is, how good is the RGB analytics compared to a Sony A6000? I'm not sure. Not too familiar with the Sony high-res RGB images, but if you're referring to the Red Edge RGB composite, you can expect about 8 centimeters per pixel resolution at 400 feet. So it's not going to be as high spatial resolution as an RGB, high quality RGB camera, but it is going to give you a decent RGB output. Someone asked, you mentioned the albedo values for the reflectance panel. Where can I find those values? If you go to MicaSense, you could actually probably just email support@micasense.com with the serial number of your calibration panel, and they'd be happy to send you the values for that panel to use in Pix4D.
And we do have a portion on our website where you can request those values, so I can send out a link to that after the webinar.
Okay, good point. A few more. Is it possible to produce 3D point clouds in Pix4D with NDVI instead of RGB from Red Edge data?
Yeah, so that we did a test case project of that with the giant Sequoia. You might have seen the video. If not, if you go in and look for that online, I can also send a link. We did that with Todd Dawson out of UC Berkeley as a test, as kind of a proof of concept, and where we were able to overlay the the multispectral values of Sequoia and to create a 3D point cloud. But a lot of that was super preliminary in terms of how you do the correction for light availability and sun angle is actually really complicated. And so even though that was kind of a proof of concept, I think to date that's not something that's necessarily on the product roadmap. It's theoretically possible, but there's a lot more academic research that needs to go in on to really determine what those values actually mean in 3D versus just the 2D.
Okay. Thanks for that.
I will add that you can use the single band values to create a 3D point cloud. You just taking the ratio and generate reflectance values is not capable. So, but you can use, the single bands to create. It's going to be a lower resolution point cloud than you would get with an RGB, but you can generate it within Pix4D.
So another question is it possible to process in Pix4D Cloud and upload straight from there to Atlas? So my understanding is currently that's not a feature available.
That's correct. They're working on the cloud all the time, and there's a pretty strong roadmap for beefing up the tools within the cloud. But at this time, it's just desktop to Atlas.
Okay. Another question is, can the client get this georeferencing feature for crop scouting in their part of Atlas? So the georeferencing tool we were discussing a few minutes ago, my recommendation, if you have a client who's going to be storing a lot of data sets in Atlas, maybe you're capturing data and delivering it to him. The best way for him to fully utilize all the features of Atlas is to just set him up with an Atlas account and then just transfer the data directly to his Atlas account. Because sometimes the sharing features do limit you on some of the tools available in Atlas. And someone has just a hardware question about a replacement cable. You can, again, if you have any questions like that, I just direct them to support@micasense.com and we can get a ticket set up for you. A couple more questions before we finish up. Someone says, which are the correct parameters to fly with Red Edge MicaSense? What overlap and side lap can I use? So one pretty good rule of thumb for flying with a Red Edge to get appropriate side lap, and side lap is generally going to be the one that's most affected by your mission planning, and I think that's what this question is geared towards, is to make sure your pass width is 1/4 of your AGL. So if you're flying 400 feet AGL, make sure your path width is at least 100 feet, if not narrower, to get appropriate 70% overlap. But typically, we need 70% side lap, 70% front lap, or better to generate a good map. One is, how do you transfer from one Atlas account to another? We don't have that functionality currently, but again, if there's enough interest for that, then we can put resources towards building that out. And then another one is, will all my jobs be stored from one summer to the next in Atlas? Our vegetation season has ended now. So that's one of the benefits of Atlas Lite, is you can downgrade to Atlas Lite once you're done with the season, and then upgrade again, and you'll have that functionality again the following season. one more question for you, Greg. Does Pix4D provide the 5-band orthomosaics or just individual tiles?
Yeah, so each band, you can see the initial orthos of each band, and then from there you're going to generate your reflectance map. So you can click through each of the bands, and you'll see the corrected views. There's also a question from someone on, is this available on Pix4D Student? So we just launched a individual student license. So if you're an academic out there and have either a single or a classroom license, you've been enabled to invite your students to purchase either a semester license for $99 or an annual license for $249, just for students only and just for faculty or staff that already have that single or classroom license. That student license is a single seat of Pix4D, but it is the full Pix4D Mapper Pro. So it's a full version of the software for students. So it will be available. You get the full suite of tools, and the button is in the most recent version of the software just to upload directly to Atlas.
That's great to hear. One more question, unless you see some more, Greg. Are there any plans to upgrade MicaSense SD card capacity? So that if you go to our knowledge base on our website, there's actually a guide on expanding the storage using a Raspberry Pi, but typically it's just not a big demand from really many of our customers. So I don't think we have any current plans to expand that capacity. Actually, I'm going to give you one more, Greg. So this is a good question. Can you explain the difference between a reflectance map and an ortho?
Yeah, so the reflectance values are radiometrically calibrated for the light that's actually bouncing off, and so that way we can do kind of absolute values there. Just like if you had a thermal camera and it's relative heat versus 98 degrees, that would be the same for the amount of light value that's calculating off for generating the plant indices. So the reflectance map is actually the kind of the light bouncing off versus the light that's absorbed by the sensor itself.
Okay, great. I think that does it for most of the questions. And if anyone has any questions that they come up with later, feel free to email sales@micasense.com. We'll get those inquiries and we'll respond to you as soon as we can. But thanks very much for attending the call. Again, apologies for the technical issues early on, but hopefully you still found it valuable. And thanks a lot, Greg, for joining the call. We appreciate the support.
Yeah, absolutely.
All right, well, thanks a lot, guys. Have a nice afternoon.